In this video, we're going to take a quick look at two questions involving applied parabolas. And the first one involves a parabolic archway, 9 feet high in the center, 6 feet high at the base. And the question wanted to know how high the archway would be 1 foot inward from either edge of the base. And as you see from this lovely diagram, I've drawn it 1 foot inward from what would be the right edge. So I'm now going to look at this diagram a little more closely and try to answer the question. Okay, so take a look now at my new diagram and see if you agree with the choices I made about how to label some points of interest. And as you can see, I'm trying to find a y value that goes with an x value that I'm saying is now 2, since it's 1 unit inward from what would be 3, and it's 3 because it's half of 6, etc., etc. So now take a look at what's next. I can name this parabola with this equation. Why? Well, it's flipped over. It may not be exactly the same width as a normal parabola is, and it's 9 units up, clearly. So in fact, let's just immediately say that the C value would be 9. Now, how are we going to figure out what that A value, which affects the width of it, would be? The negative symbol, again, is the flipped over part, so I'm not going to deal with that. That's already there. But what about figuring out what that A value would be? Well, I'm going to use one of the two x-intercepts, and the one that I'm choosing is now highlighted as 3, 0. So that should now be plugged in, and let's see how that goes. Well, that's not so bad at all. You can see that I evaluate with the x and the y in the right place, and it's pretty quick to see that the a value needs to be 1. And based on that, I now have one last picture, and that you now see has the complete name of this parabolic archway. And my last task is to use this point and figure out what the y value needs to be to match with an x that is 2. And let's see how that went. Well, that's not too bad at all, and it gives us a y value of 5. So, based on what we've seen, we are now able to fill in the blank spot on this original diagram. It looks like it is 5 feet high at that point, 1 foot inward from the edge. So that should complete it. Now let's move on to the next question. In the next question, we have a flashlight, which has a reflective mirror with a diameter of 5 centimeters and a depth of 2.5 centimeters. And the question wanted to know where you would want to have the light bulb placed so that it would be at the focus of the mirror, and therefore that would allow the rays to go outward using that wonderful reflective property. So this initial sketch is trying to represent that, and let's again move to a better sketch and see if we can answer the question. All right, you can now see this new sketch, and hopefully again you will agree with the choices I made about how to label things. And I've got that light bulb, if you'll allow that to be represented by that red ball. I've got that labeled with 0, comma A because I think that this formula will apply for this particular parabola. And remember that that is exactly where the focus should be, if I remember correctly, about all of the different equations and formulas that these conic sections may have. I think that this one will apply for this particular parabola with the position it has. So now I'm going to use one of the 2 points that I've named, and I'll use the one that I've highlighted, and I'm going to figure out what that A value needs to be. And let's see how that went. Oh, that's beautiful, isn't it? I evaluate with the X and the Y value being exactly as I chose them. And I work it through, and as you can see, I get an A value that is 0.625. So, based again on the work we've done, I think we're now able to fill in the blank spot in this initial diagram, which we are looking at a little more closely. It's 0.625 centimeter, which is equivalent to 5/8 of a centimeter above the base. So that should do it. Thanks so much, and take care.